Okay.
Do not wear bangles, bangles things in your culture.
It will be easier since here we have to just we are interested in the EMF induced. So it will be easier to work from the coil frame. With magnet frame. The coil, the question is given in the coil frame, but in any case, we can work from the magnet frame. So here is the magnet, and I will remove this boundary very soon. What kind of magnetic field it will produce? Suppose this is your north pole, this is your south. The field lines will be, can take it larger. The field lines will be, the central line will go like this. Correct? And then you will draw lines like this. Okay, it will not be wavy. This is a better line, better drawing. Something of that sort, right? This is the magnetic field produced by magnet. You draw better diagram. Now let me remove the boundary of this. After all, the material does not interact with the field which interacts. The flux change, etc., is from the field. The boundary doesn't come into picture, or the material of the magnet doesn't come into picture. So this is the field lines, and suppose I have a coil. This is the coil, far away from it. This side or that side or that. Since the arrows are this side, I can make this. Here is a coil perpendicular to this plane of the board, and if you are far away from this, magnetic field is very weak because all these things are diverging and very few lines are there, so it's almost zero. Now it is coming here, so it finds some magnetic field. Okay, so from zero it's very gradually, we are still far away, right? Here's what the magnet is, I am still far away. So a very slow rate of increase of flux. So the EMF will be induced, very good, but then it will be zero. It will be zero, and slowly it will build up. And then here the lines are much denser. Here the lines are much denser. So as it comes here, more field. As it comes here, this area is saved. Okay, and then more lines. So you move a same step, and you find that many more lines are coming. So the rate of change of flux is increasing, and therefore this magnitude is increasing. Once it is here, in the middle it's almost uniform. But if the magnet is small, you don't have that uniform region. It decreases and then increases. Ultimately, this side you have to diverge. So if my magnet is small, what will it do? It will just go like this. So you don't have that uniform region. The magnet is large, yes. Here you have almost uniform. But suppose the magnet is small, then it comes like this, it has to go like this, so there is a very small region in between where it just curves and goes away. Right? So, only this, if it is here, then the flux is decreasing. If it is here, the flux is increasing. Right? If it is right at the middle, rate of change is zero. Increasing, you find it positive. Decreasing, you find it negative. So in between has to be zero, from positive to negative. That is the symmetry point at the center of the magnet. Right? So although just left to it, just right to it, there is dividity. One is positive, one is negative. Here it is. So if you go for this dividity, in this middle point, it has to become zero. And therefore it has to bend and become zero as it goes inside. Rest is the symmetry. The diagram is like this. The diagram should be like this.
Accurate diagram.
इस लाइन से पता कर लो आपको ये शेप पता हो गई ये आपको शेप पता हो गई ये ऐसे 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 और बार मैग्नेट में कुछ ऐसा ज्यादा नहीं है छोटा बार मैग्नेट है तो द लाइंस आर ऑलमोस्ट लाइक दिस इसीलिए मैंने कहा बाउंड्रीज आर नॉट इंपॉर्टेंट राइट अब इसी में आप देख लो कि एक इक्वल एरिया दिस इक्वल एरिया इज जस्ट गोइंग हियर
और वो बहुत बड़ी मैग्नेट है और मैंने उसमें फ्लक्स मैग्नेटिक फील्ड कांस्टेंट है तो अगर मैं उसे कनेक्ट करूँगी एक्सटर्नल सर्किट से तो कोई बल्ब जलेगा ही जब मैग्नेटिक फील्ड चलेगा जब उसे बाहर निकालना पड़ेगा या अंदर डालोगे तो इसीलिए मूवमेंट जब हम करते हैं तभी होता है
1 सेंटीमीटर 1 सेंटीमीटर
कॉइल और इंडक्शन में कॉइल
ये लाइंस अलग-अलग है you can just think of a continuum you can just think as a continuum ऐसे ऐसे ऐसे
बात क्या है कि फ्लक्स चेंज होना चाहिए करंट चेंज करें तो
पानी है कितना पानी यहाँ
करंट वेरिएबल
उतना ही एरिया एक स्टेप पड़ गए कितना पानी अब यहाँ
करंट दे दिया तो जलेगा ही
यहाँ
करंट दे दिया तो जल ही जाएगा ना
इंड्यूस करने की जरूरत क्या है
इंड्यूस करने में मैग्नेट का क्या काम है
इक्वल डिस्टेंस
मैग्नेट से जा रहे हैं ना
क्योंकि वेलोसिटी इज कांस्टेंट सो इन इक्वल टाइम वी आर गोइंग इक्वल डिस्टेंसेस सो इफ यू हैव टू थिंक इन टर्म्स ऑफ टाइम एंड द वेलोसिटी इज कांस्टेंट then to get whether the flux has increased, not increased, decreased, how much it increased, what is the rate. So the best thing is आप इसको एक प्रोजेक्ट के रूप में भी दे सकते हैं okay so you have this your coil here go 1 centimeter those lines are fixed go 1 centimeter and then see how many more lines are going how many more lines are going how many more lines are going so at the near the poles in fact the concentrate is very high the suddenly they diverge from here है ना तो इसलिए यहाँ पे अगर आप 1 सेंटीमीटर आगे पीछे कर दोगे तो देयर विल बी मच मोर चेंज और यहाँ पे करोगे या यहाँ पे करोगे तो दैट विल बी मच लेस दैट्स द क्वालिटी चाय पी क्या
वो तो सही है थोड़ा डायरेक्ट है एक और है
तो हम चाय पी करके आके इस क्वेश्चन को लेके तब फिर अगला शुरू कर सकते हैं 2 मिनट में हो जाएगा चलो
काफी डायरेक्ट लगता है आज मैत्री मैम नहीं दिखी
उनकी तबीयत ठीक नहीं है
was recently a question similar to that, which the children received in their board exams, perhaps. Isn't it last year, I believe?
ये नहीं था.
So we have a coil and there is a vertical iron rod which is put through the coil, and there is a aluminium ring which is given is hanging, and there are just two statements that are to be checked whether they are true and whether the statements true. Yes. So the first statement says that there is a alternating current.
मुझे तो नहीं लगाना है कि मैं गर्दन में दबा.
There is an alternating current going through this coil. And although the discussion of it, if we want, then it is a very long one. But then for the question here to answer, we can make it shorter. So there is an alternating current flowing through this coil, and because of this alternating current, what do you think will happen? Okay, an alternating current flows in the coil. A vertical iron rod is put inside the coil of wire. The rod goes through a conducting ring as shown in the figure. The ring can float at a certain height above the coil.
This last sentence is the statement.
Yes.
Before that was the picture.
No, the entire thing is the statement.
The entire thing is statement.
Now, that is the statement 1. I don't know what is to be true in this statement because it is all statement. The ring, okay, perhaps this is the one like he's saying, the ring can float at a certain height above the coil. So perhaps they are asking us whether such a situation is possible also or not, that a ring can float in this scenario. So the statement 2 now goes, so do you believe that a ring can float?
Yes.
Okay. A current is induced in the ring. Statement 2. A current is induced in the ring which interacts with the horizontal component of the magnetic field to produce an average force in the upward direction in the given situation above. So do you think that if there is a current through this coil, if there is a current through this coil, then it will produce a magnetic field? It will produce a magnetic field? Yes. And if this current is changing with time, this magnetic field will also change with time. And there is a conducting ring. There is a conducting ring. So what do you think is going to happen in the conducting ring?
Induced current. That is some primary, secondary method. Okay. If one is induced, the other will get induced.
Okay. Now let us see again, if we go by the flux rule, let's say. What do you think would be the direction of the magnetic field? If this is the direction of the magnetic field, supposing I consider this as the direction of the magnetic field. Okay. Then this magnetic field, can it cause a change in the flux through the coil and a current in this ring?
उल्टा आएगा.
Magnetic field. So
Anti-clockwise.
No.
Anti-clockwise आएगा.
How is exerting the force? It will have two components. One is
there is
with this and the
a magnetic field in this direction. Supposing I consider this, there is a magnetic field in this direction, and if I take the area vector, I have to choose the area vector. If I am talking in terms of flux, then I have to choose my area vector, and supposing I choose it, then it will be along the ring like this. So I can take it along the magnetic field. So there will be a flux through this ring, and because of that flux, which is changing with time, so there will be a induced current in the ring. Now the question is, if you have an induced current and the ring is like this, I have this as the ring, and there is a magnetic field which is in this direction, like this. Do you think that this magnetic field can exert a force on this ring?
Yes.
What is the relation that we know of the force?
BIL.
What is the relation that we know of the force?
I cross B.
I cross B. L cross B. If there is a current, then it will be along the ring only. And if I have this as the current direction and this is the magnetic field, then what do you think will be the direction of the force?
It's like that.
Okay, we are coming to that. So, do you think there will be a force? Yes. But its direction, what will be the direction of it? It will be ऊपर की ओर नहीं होगा. That's exactly what I wanted to hear. That ऊपर की ओर तो नहीं हो सकता है, because I have a vector like this and I have the L vector. It is like this. So if I go from
Again, right. Induced.
this to this, then my force is coming like this.
That's what force is there.
If the ring is to hang in space, is this force responsible for it to hang in space? So what do I do now?
B.
Is this the magnetic field? Is this the direction of the magnetic field?
Then that is
Have I made the correct direction of the magnetic field?
that. No.
How am I sure? ये रिंग की ही तो मैग्नेटिक फील्ड
Lengthy
है.
हो गई,
जब भी
magnetic
there
field
is
हो
a
गई.
current
तो force
in a
किधर हो
coil,
गया?
there will be a magnetic field. Here the
गलत
only
कर रहे हो, इस वाले
difference
हाथ से
is
कर रहे
that
हो,
because the
ये वाला
current
इस हाथ
is
से करते हैं, ये वाला इस हाथ से
alternating,
करते हैं.
the
अब बस
the
एक
magnetic
करते
field
हो.
is not constant
This is
in
force,
time. It is
induced
also
current,
changing with time.
Induced current के लिए तो right है.
ये दोनों एक से भी हो जाए.
चाय पी के आ जाते हैं,
इससे भी
मुझे
हो
लगा
जाते हैं
5 मिनट होगा सर.
इसमें मैथ्री रैंप नहीं है तो सीधा रैंप का मन नहीं लग रहा है.
हाँ
तबीयत कैसी है सर उनकी? हाउस मैम.
अलग अलग एवरी